All right. Thanks everyone for the time. I appreciate it. I'm Max. Max Collins from University of California, Irvine. And I'm going to be talking today a little bit about an application that we've been working on for a while, called Vizme, specifically the remote collaboration aspects that we've been building onto this app. So like the slide says, I'll be doing an overview of the design and evaluation of this remote collaborative AR system, specifically looking at how we can use this for educational use. So a little bit of background. The way that I got into this project is actually through the Blue Water Student Internship Program. So that was when I was at University of Illinois Urbana-Champaign during my undergrad, and I was an intern during the year 2015 through 2016, and that's when I started working with Dr. Craig. So Alan and I have been working together for quite a while now on building AR experiences, AR apps. This app that we've been working on is called Vizme, and it's for visualizing all the molecules in the protein data bank. And I'll get to some more of that in a bit here. But first, I want to talk a little bit about some of the goals of this work specifically. So like I said, Ellen and I have been working together for a while on this application that I'll detail in a little bit. But we've been really interested now in thinking about how we can leverage AR for remote collaboration. And like I said, thinking about doing this in the milieu of education, and thinking about how we can instill this feeling of handing objects through the screen between participants, and using AR to instill that feeling. So we've been working on building this tool that would be useful for instructors and students working in this remote model, especially given that we're all kind of, we've been stuck working in this model for quite a while now. And see if we can understand how to increase feelings of collaboration, communication, that sense of feeling that we are sharing an object, and maybe not just copies of an object, if that makes sense. Why are we doing this? Some of the motivations behind this are understanding how we can improve collaboration, if we can improve collaboration when working in this remote model, how we can leverage AR to do that, how we can exploit this sense of proprioception, right? Like how our body is engaged in what we're doing. And furthermore, just engagement in general. And also, is there anything that we can do around accessibility and reach to more people by leveraging the fact that you might not need physical real world objects in your space to interact with objects that might seem or feel like they're physical real world objects. So a little bit of background on what AR is. So this is the definition that that we subscribe to from Alan Craig. So augmented reality, a medium in which digital information is overlaid on the physical world that is both in spatial and temporal registration with the physical world, and that is interactive in real time. So I got a picture over here. I think you can see my cursor, but this is a picture directly from my phone, and this is I took a screenshot while using an AR app that I made outside. So the thing that's augmented in this picture is actually just the grass. Just kidding, it's the transformer. So the transformer is not the real thing here. It's just digitally overlaid onto the physical world here. So there's a couple different types of AR that we're particularly interested in. So we've got marker-based AR and then markerless AR. Markerless AR, this is just a really quick video to show you what that looks like. So you can see I'm recording this video directly from my phone, and I've stuck a digital tree in my living room. And I'm walking around the digital tree, and you can see that it's registered right onto the real world here without any need for what I'm calling a marker. And if you want to see what the marker or marker AR would look like, here's an example of that with me with hair that's way too long. But I've got this target image here, the marker that is registering where this digital model is going to be placed in the physical world. So you can see it's rigged directly to this sheet of paper here, which is acting as the marker. And that's all we need for that. So A little bit of background on this app that we've been using to study this. So I mentioned this before, but Vizme is an app that we've been working on for a while. And it's used to visualize any molecule in the protein data bank, the PDB, which has like hundreds of thousands of models that researchers are constantly adding to, and other curated scientific data. So we wanted to build a tool that could easily visualize any of those models without having to store the whole thing on a personal device or a mobile device. So in real time, you can import models from the PDB and visualize them using your phone and manipulate them in AR. And you can do this in various representation styles and manipulate them in different ways. And you can also, this is something that Alan talked about in a previous talk for the June 2019 ECSS Symposium. And here's the title of this talk if anyone wants to go and check that out. And there's also a full paper on this here. And I think that we'll be uploading slides after anyways, if anyone wants to get that link. Quick background just technically on how Vizme is working. So like I said, this is a mobile phone or mobile device based AR experience. So you've got the app running on your device. And when a participant or when a user types in the code for the PDB item that they want to visualize, an HTTP request is sent to the server that's running this program called VMD, which then can request molecular data from the protein data bank. And send that molecular data back from the PDB, run VMD to spit out the model or file type that we need that plays nice with the app, then send that geometry rendering the molecules back to the app in the file format that we need. So we're using .obj files and material files to do that. So to see what that looks like, I'm actually going to turn off sound here. So this, as you can see, it's using that marker-based AR. So this model of the molecule here is rigged directly to that target image. So a user can type in a PDB code, which is usually like a 4-digit code, select their representation style that they're interested in viewing in, and then hit import. And that model is going to be downloaded and imported directly from the PDB. And let's see, this is just showing that you can look in various representation styles, and we've got it rigged to the target image here. So this is what we were working with when we were thinking, how could we, oops, trying to go to the next slide. So we had that in action. We were thinking, we actually got a question last time. Alan got a question asking about the collaborative nature of this, or how you could exploit working collaboratively with people using AR, using this experience. And that's something that we definitely been thinking about. Yes, question from Mona on that. So we were definitely glad to get that question, because that was something that we've been thinking about. But this last year is kind of, for lack of a better terms, forced us into thinking about how we could do this in like a remote sense, right? And it's kind of interesting, like there's, you know, of course, like different ways to accomplish like collaboration, right? Like you can collaborate in person, in close proximity, or collaborate remotely or synchronously or asynchronously. So we were thinking, how could we leverage AR and what we've got already to collaborate in a remote sense? So like I said, given the uptake in remote work, we designed or set out to design this remote collaborative AR experience around Vizme, around what we've built. So exploiting some of the capabilities of Zoom teleconferencing calls. So we, you know, when we're on a call like this, I'm sharing screen right now. I'm sharing a set of slides that I've built before. We have shared video and audio. You can see and hear me right now. And that goes two ways, right? So the way that we wanted to do this was, you know, using what we've done before, but then also building on top of that. So we've got this, we've got these target images that we've built, or that we're using from Unity and Vuforia. So technically how it's working is, you know, we're building the experience in Unity using the Vuforia library, which lets us have target images like we saw before, and rig models or whatever we want to those target images. And those target images can be on paper, like textbooks, worksheets, or a computer screen, right? So in a Zoom call, for example, if I'm sharing my computer screen, you can imagine that I'm sharing a target image, and then when viewed through the lens of the smartphone or whatever device that someone is using, whatever information I want overlaid on that target image, I can then, in a sense, pass through the screen to the participants to examine on their end. So the way that we imagine this going, is multiple participants join a Zoom meeting. The driver of that experience can then share screen, like I'm doing right now, to display relevant target images that will rig the desired assets to those target images. And then participants of the meeting will be able to observe the presentation through the lens of the phone or device to see that AR information overlaid onto the presentation slides. And then from there, people can manipulate those objects. We can do kind of some fun things around remote control or remote participant visualization. I'm going to get into all this in a bit here, but just kind of this is the overview of how we were imagining this going, and how we could exploit that fact that we have target-based or marker-based AR. So here is a demo video, just kind of showing what we've been working on with the remote collaboration aspect. So we were thinking, how could we make these Zoom calls more interactive? So this is actually a clip, a screen recording of a Zoom call. So you see me in the corner talking, and I'm talking about this model of ethanol, I think it is. And just using a 3D viewer to show participants of the call what this model looks like and show the 3D nature of it. So now, instead of just showing a screen share or screen recording directly from that Zoom call, I'm actually now recording from my phone. So from the device, that's why it looks a little bit fuzzier or different now. But you can see I'm looking at my computer monitor through my device, recording through the iPhone. And then when the presenter, me being the presenter, when the presenter decides that they want to change to an image target on the screen, now this model is in the participant space that they're viewing through their phone, and the participant can use their fingers and on-screen touch controls to manipulate that object in ways. So you can see I'm moving around in my physical space, and I've got my computer monitor here, and the object is now rigged on top of my computer monitor for me to visualize in my space. And I can also just set that as my Zoom background and get out of the way and let participants see it that way. So here's what it looks like from the third person perspective. That AR model is rigged on top of my computer screen, and I'm still in that Zoom call, right? So whoever is driving that Zoom lecture can have as many target images as their background or on slides as they want to, and share things as they're going through a lecture or a presentation, to make things more interactive and, in a sense, hand those digital objects or those objects that they're talking about through the screen for participants to further examine. So another here, let me go back for just a second here. Something fun that we've been playing with is just being able to change the target images. Obviously can change what models are being displayed. And it's interesting because a remote participant, or like the driver of that experience, can be changing those target images, of course, whenever they want, which then subsequently changes what the participant of the call or like the remote collaborator is being displayed. So a remote person can kind of be in control of what they're showing you in your space, or what they're handing you in your space, right? So the presenter can choose the model presented by switching through slides here. And then you can see that users can take on-screen manipulations to rotate and scale the object. So I'm using, like the touch finger controls to move around, and I've got this thing in my physical space. And you can see this is using marker-based AR, right? So it is rigged to that target image. Technically, that's how it's working. Something else really fun here, and this is something that we're super excited about, is this idea that we can use the fact that we're using target images. We can use that and then place items relative to each other in the in respective physical spaces. So let me try to explain this in the best way possible. So this experience is showing, this is a direct recording from an iPhone screen, running the application, watching a presentation in a Zoom call, and there's a remote participant also participating in this call. And they're represented by this pencil pointer here. So I'm gonna let it play for a second. This remote participant can control the model. So the participant in recording right now is not actually using any touch controls or anything, but the remote participant is using their touch controls to change it for all participants of the call. And then the remote participant is also represented using this pointer, which is a pencil in this case. And you can set, and the way that we accomplish this is using the target image to kind of set people in the physical space relative to each other, even though they're not in the same physical space. So I can know the exact position and yaw, pitch, and roll, the rotation of that participant using their phone in a remote place, because we've got, we know how each other are situated due to the fact that we're both looking at this same target image. So I'm seeing how a remote participant is looking and pointing out things to me by moving that model for me and pointing things out using their pointer or their visual representation in my physical space. And this is just showing that, you know, this is exactly how the remote participant is moving their device around, and that pencil is following exactly their movements and their rotations based on the fact that the camera can see the target image. And we're comparing this also to just like a typical 3D viewer that's non-AR. Switch sides here. So this is just another image of what that pencil looks like, the pointer. It doesn't necessarily have to be a pencil, obviously, but we were thinking for educational context, you could imagine a teacher showing a student something, right? And they're in their own respective places, but they can both kind of be together and look at the same object. They can both manipulate things on their end and have those changes propagated to each other, and then point things out to each other as well. Should also be noted here that we're using, for the study that we've been doing, which I'm going to get to in just a second, for evaluation of this, we kind of boiled down to very, very simple models, just using like simple ball and stick models, because as opposed to like the more complex ones that we saw earlier in like the Vizme demo video, because we felt for user testing, it was a bit easier for the tasks that we had for the participants. So talking a bit more about like that evaluation, we went into this wondering, does demonstration leveraging AR enhance the sense of co-presence and collaboration between remote pairs who are collaborating, especially when compared to traditional means of teleconferencing? So to do some user testing, we set out with 5 different conditions that we're calling them, and we presented these to participants in a within subject design in random order to try to counterbalance some carryover effects. But we have 5 different conditions, like I said. So first condition is using augmented reality with touchscreen manipulation. So that's just kind of like a very simple AR. The participant is using their device to view the presentation slides, and they can use on-screen manipulations to move that object. 2 is similar to that. So it is using AR, but there is no touchscreen or on-screen manipulation. So in order to change their perspective on the model, they're going to have to physically move themselves around in their space to understand the 3D nature. And the task here is we're having people look at models and then categorize them into different molecular geometries. Task 3 is similar to that video that we just saw with the pencil. So it's using AR, and there are those touchscreen manipulations that a participant can take on the screen. But there is also the remote demonstration. So a remote participant, which is in the user test, me, can take actions, and the user will see those propagated on their end, like the rotations and scale of the object. And also you see that visual representation of the remote partner, which is the pencil. 4 and 5 are using no AR. So 4 is no AR. but there's still touchscreen manipulation. So just like a basic 3D viewer or 3D visualizer. And then 5 is similar, except it's also using remote demonstration. So there's no AR. Participants can use touchscreen manipulations, but then there's also remote demonstration. So on the other end, a remote partner can move the object in that 3D viewer, and then all users see that propagated on their end. I also want to mention too, for that like condition 3, with the visual representation of the pencil, you can imagine that there's 5 people, 10 people, multiple participants in a call, all with their own visual pointers or representation. So it's not just required to be like 2 people or like a dyad. And then the participants that we've been working with are students and instructors, mostly at the graduate level, and researchers. So the way that we've been doing this is, like I said, that within subject design, we're having people look at each of the conditions or experience each of those conditions in random order. And then we're having them fill out a questionnaire after they experience each condition. So we're using a spatial presence questionnaire, a task load index questionnaire, and then a user experience questionnaire. These are just some examples of like what a question might look like from each of those questionnaires. And then after the entire experience, we're also doing a qualitative interview, like a semi-structured interviews after everyone sees all of the conditions. And those that we're particularly interested in how that like qualitative portion is going to then color the rest of the data that we're getting. Because, while the questionnaires are great and they're validated measures, they're not necessarily designed for these types of experiences, these AR experiences. So I think I know already we're getting some really great feedback, particularly in those interviews after. So just some preliminary findings. I've kind of been breaking up. I've been doing some like thematic analysis on the interviews and how I've been talking to people, and I kind of broke down just 3 big categories here, and I got a couple of quotes and some bullets here that I think are pretty interesting. So we've got collaboration, and this is from one of the participants that I talked to who said, I've had meetings where I had to present something to a collaborator like a PowerPoint. And then in that case, I can have a cursor and point something out. Other people I'm talking to don't have the ability to actually point out something they want me to see right now. So it's very one-sided. Being able to see the other person's position was helpful, but also you being able to interact with the model with AR. So this person who's a structural biologist was saying that sometimes they'll be wanting to show someone, some model that they're working on. And it's really easy when you're in person to show someone, I'm looking at this thing here and I can see that other person, the angle that they're looking at it with, or if I move it, I know how they're looking at it. But that's kind of lost in a lot of like remote collaboration. Like if you're just doing a video call or working on a Google Doc, but they felt that this kind of gave them that ability back to see how someone else is looking at something. And then some other things that are coming up is they're being able to share the object and change an object together so we can manipulate it. I can verbally say, okay, now I'm going to move to this thing around on this axis, and you can see that happening. That really increases that sense of collaboration and communication when working remotely together above just like traditional methods of collaborating. Then also user engagement. So a participant said, I definitely feel more excited if something like this was to appear in a presentation as opposed to just sitting through all these Zoom presentations. Could also be fatigue. The fact that I've been sitting in front of Zoom presentations for a year now. This is the first thing that's actually stood out as being different. So it definitely seems that this, whether that's just the novelty of AR, which I don't think is a bad thing at all, to exploit those novelty effects and the like general interest in using AR. Another participant also pointed out that this would tie up their students' phones and focus, like for high school students, for example. Right now, there's lots of Zoom calls that take place where people are not really engaged and they, have cameras off and stuff. But if we have the phone tied up and we know people aren't just texting and not paying attention and their device and their focus kind of have to be focused, that could do wonders for engagement in the subject material. And then also explaining that sense of proprioception, right? Like a participant said that while they're more used to like those touchscreen interactions due to, like the metaphors that our devices commonly rely on, changing the view here, like in using ARs as easy as, looking over versus getting my finger and scrolling through the thing, seems more natural. So just being able to look around something how you would an object in the physical world. This is kind of an intimidating looking, but not too complex actually, graph just showing like how participants are ranking their preferences of each condition. So like I said, I lined out those conditions. Oh yeah, I'm running short on time. So this is, I'm almost done here. But this is just basically showing that that condition with the pencil pointer is like overwhelmingly ranked as their favorite or most preferred. And also that just having AR is more preferred above non-having AR in these remote collaborative scenarios. And then for what's next, we're going to keep working on this user testing. So finish up user testing, which we're almost done with, do some data analysis. We've got the quantitative to do, but also the qualitative, and then add some features based on the user testing. And then just consider topic areas for and other domains to apply this to. I'm going to wrap up actually just to take some questions now.
Great, thank you, Max. That was fantastic. I saw we had one question earlier from Sergio, and Sergio, Alan Craig had waited.
Unless somebody like wants to elaborate a bit, but I mean, if you look in the chat, I mean, I'm happy with Alan's answer. But basically, my question was, what are the requirements for the participant on the device that the participant needs to benefit from this? But I think Alan answered that, so I'll defer to others.
Okay, yeah, I think Alan got that pretty much covered.
And there's a question from Mona. How many people in the study? What's the name of the app, and is it available now?
Okay, yeah, good question. So far we've talked to 16 different people, and we're aiming to talk to about 20 people total. And then it is not available yet, but it doesn't have an official name, I guess, right now. But hopefully that'll be coming shortly. There is no website for this version of it yet, no. But we do have, and I think that these slides, like I said, could be posted. We do have a paper on like the initial Vizme, and also some information on my site about Vizme, but this Vizme plus like the remote collaboration, we don't have that up yet just because we're still in like the testing phase here.
So Max, this was fantastic. I'm thinking many years ago when I was taking organic chemistry, I would have loved to have something like this.
Totally, yeah.
And of course, this would be a little before your time, but when organic chemistry textbooks or classes were trying to show the 3D structure, there's those dotted lines going into the page, the dashed lines coming. Oh, it was so hard to wrap your head around.
Yeah.
And even with the visualization, just being able to take and manipulate would have made these things so much easier.
Yeah, we hope to be able to give some of that back here.
Yeah.
Plus the benefit of reducing Zoom fatigue are just very timely.
Yeah, the instructors that we're talking to particularly were very excited about something like this.
And let me just ask one specific question. So I saw that you were manipulating the object. So you took, for example, the model of ethanol, and you were able to zoom in, zoom out, rotate it. Can you actually manipulate the molecule? So for example, rotate about a bond, or are you just restricted to rigid body motions for now?
You could definitely do all of the above. It totally depends on like how we, so yes is the answer. And I think that, so if you're saying like maybe we could, it all depends on like how you're constructing the thing, pretty much in Unity, right? Like, so we could add, I was playing for a while with this, this feature where you could kind of build your own model or build molecules like in space. And you can, then imagine you're taking things apart or removing bonds or adding bonds and seeing how things interact. So, and you can have animations and stuff. So technically, totally all of the above is possible. For what we're doing here, it's super boiled down, because for the user test, what we're having people do is take a look at a model and then categorize. I don't know, you can kind of see these buttons down here and these images on the side, but we're having them categorize into one of 5 molecular geometries. So they're looking at something super basic that they don't need like prerequisite knowledge about, but it's slightly more information or more interesting maybe than like, hey, look at this cube. Is it a cube or is it a sphere? So that, yeah, we were thinking like just for the user testing, how can we like isolate and test these interactions in a way that's like somewhat applied?